So hello and welcome everybody to our AGRIBALYSE 3.0 live stream for openLCA. Today we are joined by our colleague Vincent Colomb from ADEME and the two of us, Suas Pala, my colleague here from GreenDelta, and myself. And I think for the start we can just all introduce ourselves and tell about our role in this project. So maybe Vincent, if you would like to start.
Good afternoon, good morning. I'm very glad to be with you this morning to show you our work. I'm Vincent Colomb. I'm working for the French Environmental Agency, and I've been coordinating the AGRIBALYSE program for the last 7 years. And so I will explain you everything about our work and the data that we are providing now.
Thank you, Vincent. Maybe Suhas, you want to introduce yourself too?
Yeah, thank you, Tim. I'm Suhas Pala, and I'm an intern working at GreenDelta. I have been working here since 2 months, and I'm working with the AGRIBALYSE database. And using this database, I've created a case study in openLCA, and I want to present this case study here today. And thank you. Over to Tim.
Yeah, thank you. My name is Tim Lose. I'm working here at GreenDelta as a sustainability consultant, and I will show you how to put the database into openLCA. So for today, what we would like to do is first introduction of the AGRIBALYSE project and the database itself by Vincent. Then we're going to go through the case study from Suhas, and then I will show you how it works technically. So yeah, let's get started with Vincent's presentation.
Thank you, Tim. So I will give you a broad view about our work. You can go to the next slide. Today, the idea is to tell you a bit about the history and how did we get here today. So because the program is already more than 10 years old, so it's important to have a vision of the global dynamic. What the new data that we are providing, because there are some previous versions of AGRIBALYSE, so it's important you see all the new inputs we provide. And then we'll have a short look at the methodology highlights and give the floor to Suhas for a case study. And then we will try to give you some outlook on the future and the new project that we are developing right now. So we just would like to know a little bit about who is online, so we can also adjust for the best the presentation. So we invite you to click on the polls on the YouTube live session.
So we put the polls in the description of the YouTube link. If you can click on poll number 1, you will find it there. And then you can vote, and then you can also see the results of the poll on your own screen if you click on the results. So we're just going to give you a minute to, to click. Maybe you can. Yeah. And then if you have voted, there's a result button. If you click on it, you can see the live results of the poll. So maybe Vincent can explain it better, but basically we're looking to see who is our audience, where does everyone come from, and then how does that relate to a database that is based in France.
And so you can click on poll number 1 and poll number 2. That's a very quick question, and we wait 30 more seconds, and then we will go back to the presentation.
Oh yeah, right. So if you can do actually both polls, poll number 1 and poll number 2, and then we're going to have a good idea about your backgrounds, where you come from, and what is your basically your interest background, your educational background.
Okay, I think we can move on with the presentation.
So yeah, the polls results are in. think it looks good. Yeah.
We have, as expected, considering the time of the year, not many people connected, but the idea is that the presentation will be online and can be also watched afterwards for the openLCA users. So that's not a big problem. So about AGRIBALYSE, the program was started in 2009. It was with political support to develop a framework to promote sustainable production and eco-design in the food sector, and as well to also provide a framework for eco-labeling and environmental communication for the food products. And to attain this goal, we needed to have a good and robust LCI database for agricultural products. So that was the launch of the AGRIBALYSE program in 2009. And we reached the first publication in 2013 when we were focused at the time only on the agricultural stage with providing average data for the main agricultural products from France. Then we had some updates during the following years when we included more feed data, and we also tried to include some data that were not representing only the average production system, but some production system with environmental benefits, so eco-design system. And so that's how we reached the AGRIBALYSE 1.3 version, which is the one that has been provided since 2018. Now we are publishing the 3.0, so it's a big step for the program, as we are totally changing the scope, the perimeter, with a new data and a new approach that is now from cradle to fork. So we moved from the farm to the final food product. We also created all a new design for the program communication and a new organization, new partnership. So it's a big step, this new version of AGRIBALYSE, and that's what we're gonna present you. What is to keep in mind, it's really that it's been a big collaborative program at the French scale, which has included a lot of people, a lot of contributors. So the leaders from the beginning have been the ADEME, so the French Environmental Agency, with the support from the Environmental Ministry, and the INRAE, which is the Food and Agriculture Research Institute in France. So we have been driving the program, but there's been a lot of contributions from technical institutes, from research, from universities, and also consultancies, each one with his own expertise on some food categories and agricultural product or specific topic. And so at the end, this new version is building over all this expertise, which has been, we have evaluated, it's more than 100 people who have been contributing directly to AGRIBALYSE program. And also with connection with international teams, as the PEF program, the AgroStuff, the Swiss teams, which have been supporting us. This latest version, 3.0, has been developed specifically by the group of consultancies, with Blanc Consulting from the Netherlands, and two French teams, Ginkgo 21 and Sayari for the France. So it's been also within this team quite many people involved. We've been making great effort to make this work available, and also a big contribution by Peter Koch Consulting, who's been doing a big review and who is now working on a fixing patch. I will explain a bit later what's in there. What is important for us is that, well, our work and our database is really focused on the French perimeter and French scope, but we really think it's important to connect with all the international initiatives. And so we are also making the data available through the GLAD program. We are connecting with the PEF, also looking closely with the LEAP and other initiatives. And we are building our work also with the support of background databases as EcoInvent, and also data from World Food Database for all the imported. And so it's really important that where food is a global market, and we really need to have a good collaboration between the initiatives. It's not one country or one initiative which will be able to provide all the data for the world and all the users, and we really think we need to get a good cooperation between all the LCA practitioners. So compared to the previous version that was focused on the farm, now in AGRIBALYSE we have a lot of new data. So can go to the So you will find in openLCA all those data. So we have a lot of agricultural data with a lot of different production systems. We have conventional systems. We have like more high quality systems and organic systems. And we don't use those agricultural systems in the food data at the end for the final food product, but we provide them for the user. It's available. And so you can use them and switch the raw agricultural material with other production system if you're interested in, and you can explore the different options. So until now, the previous version was focused on agricultural products. And so with this new step, we include the import, the processing, all the packaging and logistic, and also the preparation at the consumer. And that's how we got to the AGRIBALYSE 3.0. What was the request for the development team at the beginning? It was to align with the French nutritional database SQL, so to make it easier to combine environmental and nutritional analysis. It was to build a transparent and well-structured database that will be able to evolve with new data in the future. So the idea was not to make a very, very accurate database, but it was to have a broad scope and be able to improve in time. And the idea was not to develop look for new primary data, but to build on pre-existing LCIs and focusing on the previous work from AGRIBALYSE, work from World Food and EcoInvent, also to keep some consistency. And we did not want to get data with different quality level and different methodology. And so we wanted to keep a harmonized structure. The request was really to focus on the hotspots in priority. So agriculture, try to make some consumption mix to reflect the importation of a food product in France, and to look into a bit more detail in some flagship products that are highly consumed in France, and when we know there are some environmental challenges and interest from the food people, but also from the NGOs, from the media. And so we had some a bit more focus on a limited number of products. Also, it was important that we would focus on data that are less available. For example, for the food companies, it's harder to have data about agriculture production, but for packaging, it's very easy for a food company to know which packaging they are using. So we put less effort to build packaging data because users can adapt easily. We went for the full scope, so really from cradle to the fork, but with simplification, especially on the steps that are not really hotspots, such as logistic, processing, and so on. And it was really important considering the broad scope of the data and the innovative process that we had a strong review. And so that's been the case with a review from ADEME, so the Dutch Environmental Agency, on the initial database, so the first version of the database. We also had a review from GreenDelta teams on the methodology and the DQR approach, and we had the core consulting who made the review on the final data. The conclusion from the review was that the database is really innovative and useful for sustainability analysis, that the main results are consistent with the scientific data and the existing publications, The database is suitable for hotspot analysis, so it's useful for eco-design, but there should be caution when comparing very similar or close products because of the hypothesis and the proxy that has been used. So it's really important that when you compare two very similar products, you look at the data quality ratio and consider really the hypothesis that has been used, because sometimes you can make wrong understanding because possibly some very similar products have been modeled in a totally similar way and you don't have difference in the modeling, whereas the products are different. Also, we identified some improvement options for future version, and we have a clear and a shared vision that today the LCA indicators are not totally complete for a complete comparison of agricultural system. On biodiversity and pesticide, for example, we need more research and more indicators, more robust indicators to properly compare the agricultural systems. The kind of results you will get with using AGRIBALYSE is you can have very easily analysis, contribution analysis for each step for each of the products. So know where is your key topic, if it's more the processing, the transport, the agriculture. And you can also have contribution analysis by ingredients for all the recipes. And the same, you can see very quickly which ingredients you should focus for your sustainability strategy. And to conclude this introduction, to give you a broad view about the database, we cover all the big food categories that are consumed in France. And in line with the nutritional French database equal, and we reach about 2,500 food products at the end. Now I will give you the key hypothesis that we've been using for the modeling of the food products. So I can't in a short time, like half an hour, give you all the details, but I invite you to really look at the methodological reports and all the documentation that we provide. It's in French and in English, and we really try to be very transparent about our methods. And you have all the documents online. So if you want more details, you can go after the presentation and look at that. So we worked if we want to model a food product, we really need to start from the agricultural raw material. So we define, for example, for a pizza, you will have to start with a tomato that is used, or agricultural tomato. And so we made a consumption mix to reflect the tomatoes that are consumed in France. So with import from Spain, consumption from France and Italy, for example. And then you need to process this tomato to make the tomato paste. So we went to look for processing data from EcoInvent, World Food Database, and Acivia, which has been the French food processing program. And then you need to cook this pizza. So you have, again, some processing and energy data that you require. You need to know the recipe of your pizza, how much of each ingredient. And then you need to add the packaging of the pizza, the transport, and the cooking at the consumer stage. So, and we've been aggregating all the data along all the value chain. So you find all the data in a transparent unit process approach in the database. And we define different steps. And so the data are built in a Russian doll scheme. And so you have the data at plant, where you have only the recipe with the raw material. Then we add the packaging, the distribution, the riddle, and you have the final product at consumer that is aggregating all from the farm to the final steps. And you find this in the openLCA with the nomenclature telling you which step you are in the product development. So I will now explain you about the main step. So the consumption mixes, it's where we account for the import of the different agricultural products. We've been working with the FL-stat and considering 5-year average product to define for each product. So for like tomato, we look at the French market, and we know that maybe like 30% of the tomato consumed in France is from Spain, 20% from Italy, and the rest is produced directly in France. And so we made this consumption mix representing the different origin. And we made this for all the products that are used and consumed in France. Then for the recipes, we try to be in line with the nutritional database. So we use the ANSES recipes, and we complete them with a retailer for data that were missing. So we had the recipes that were given to us directly by a retailer. And also some recipes for some from processed food were already available in the World Food Database or EcoInvent data, and so we did not modify them. So that's the case, especially for intermediate products. What is important to notice is that the recipes are homemade recipes. So we know it's a big hypothesis, because if you use industrial product, you will not have the same quantities. You will have some specific ingredients that you don't use at home. So for example, some sugar, glucose syrups, and these kind of things that you don't use at home, but that are used a lot in industry. And so if you compare the AGRIBALYSE food recipes with the industrial product, you really need to look if the recipes is coherent or if you need to make some adjustments. For the processing, we assume that all the processing was happening in France. So we did not account for food products that are processed in another country and that we would import directly processed. So that's also a simplification. We focus mainly on energy and water demanding processing. So we know like all the heating, the cooling part is have a stronger effect on environmental impacts. But so for all the mechanical processing, like unshelling, peeling, pitting, this kind of processing, that we know they use very little energy, and we made some big simplification, or sometimes we even use some dummies. So it's empty processes. Also, there was a lot of data where we could not find really accurate processing data, and we made some proxy simplification. For example, for all the plant-based drinks, so like soy drinks, almond drinks, and so on, we only had one process for the pressing, and we did not account the difference between the different kind of plant drinks. So it's only one for the whole category. It's all the same processing. For the packaging, we use also some approach by category. So we define 13 categories of products. And for each of them, we define a standard packaging that was reflecting the French market. And so, for example, for fruit and vegetable, we consider no packaging, as we know that in some cases there are some packaging. For alcoholic beverage, we only use glass packaging. So again, it's a realistic assumption, but in a case by case, it's important that the users they look and they check if it considered it's corresponding to their situation. Regarding transports, we had a transport chain that was built with a transport modeling, with the first step that was transport from the production, so from the farm to a hub. And then we had a hub to hub, so that was for imports especially. So for example, we consider a distance from the Brazilian farm to the export hub in Brazil based on the Eurostat data and grid for USA and expert judgment with a Blanc model that has been developed. And then, so we add the transportation from the hub, so from the Brazilian hub to the French hub, that will be a big port, using Eurostat and Google Map distance. And then we add all the final logistic within the country, where we use the distance of 450 kilometers from the port to the distribution center in France, and then this distribution to supermarket. And what is important to notice that we did not consider the distance from the consumer to home to the supermarket, because it was highly variable and it was not really connected to one specific product. So we decided to simplify and to not account for it. Also, we know it can in some cases be significant. For the retail and preparation steps, we align with the PEF modeling approach. We use the raw to cook ratio which is quite important and is affecting strongly the results. So to get the final product at consumer, in the cooking, sometimes the product will gain weight, sometimes it will lose weight, depending on the kind of product. And so we define this ratio. We also define a ratio for accounting for the enabled losses. So for example, for the bones in the meat, we did not account for edible losses, because again, we thought it was a consumer choice and it was not directly related to the product. And so we only consider the losses that are structural, like the bones, and not the losses that are good products that are thrown away by the consumers. We consider some archetypes of preparation types. So basic boiling, cooking, microwaving, based again on some categories of the products. For all the energy and water consumption related to this cooking, we followed the PEF approach. And the last point I wanted to share about this methodology is the DQR. So for each of the 2,500 products, we provide a data quality ratio aligned with the PEF standards. So it's telling you how good is the data reflecting the real situation in France. So regarding the technology, for example, is the production methods, the agricultural product corresponding to the really what's you will find on the market, or did we, or maybe we had to make some proxies, and for example, we could not find data about the grapefruit, so we consider orange as a proxy, and so this will be reflected in the DQR. And so at the end, you see that in all the categories, you have most of the products have a DQR compared between 2 to 3. So 1 is a very high quality data, and 5 is a very low quality data. And so our database is mainly in between, with the DQR in between 2 and 4, which makes sense consider our initial targets. But when you compare products with DQR that are above 3, you need to really be careful, because it means that we have been using quite a lot of assumption simplification. And so you need to check them before. You cannot make direct comparisons.
Yeah, thank you, Vincent. I'm sure our viewers will have a bunch of questions about that. We're going to do a Q&A session at the end of the live stream. So I can ask you guys just to write your question in the chat window, and then we're going to go through all the questions one by one when we reach the end of the live stream. And so now I would like to, my colleague, he can present his case study about pizza.
Thank you, Tim. Hello again, everyone. I'm Suhas. So I'm going to present you my case study in openLCA using AGRIBALYSE, and I hope this would provide you basic understanding of how this works, and also to find results about particular research questions in this area regarding food industry in France. So researching about this, I found out that France is one of the topmost country in consuming pizza in Europe, and also some of the favorites among the French people are pizza Reina and pizza Margherita. Reina is made with ham, mushrooms, and cheese. Also, the average annual consumption of pizza is about 10 kilograms per head. So, moving further, the goal of this case study is to model the frozen pizza production and the transportation process in openLCA. This case study has its scope until from cradle to gate, and the use phase and the disposal phase is not included. As you can see here, there's a flow diagram indicating 4 stages of production as well as packaging, and then transport to distribution facility, and finally transport to supermarket. Here at each stage you have an input flow and output flow, and finally the desired pizza would be at supermarket after the stage 4. So with this, there is an attempt made to understand and indicate which variants would cause higher impact in environment. So the assumptions made in this case study is the cooking process for the frozen pizza is similar to the one which is already in the AGRIBALYSE database, and the industrial plant, the poultry farm, and the agricultural farm, which are in the background processes used for obtaining the raw ingredients, are assumed to be in same location, and the logistics among them are assumed to be negligible. And the third assumption is that among the pizza market, 60% of the market share is assumed to be of frozen pizza, which means of the 10 kg consumption, 6 kilograms of annual consumption per capita is for frozen pizza. And while creating different variants of these pizzas, there were some extra ingredients added on top of the regular recipe. So the other ingredients and their proportions would remain the same when these extra toppings were added. Also, the final assumption is that the background processes such as heat, electricity, water supply, and transportation are all similar in all the cases. And moving further, we have the life cycle inventory, and this is how a process which is created in openLCA would look like. And as you can see, there are 2 sections, which is inputs and outputs. As mentioned earlier, each stage has 4 different input flows, and in openLCA, we could add all of those input flows in one single process in the input flows process, input flow section, and the output flow would be the final product which we need, which is pizza Reina, packaged at the supermarket, transported. So also here the units are in kilograms for the weights and kilometers for the distance to be transported. And you can see in the amount column the text such as extra underscore ham and extra underscore Gruyere cheese. These are the parameters used in order to customize the weights of particular ingredients if we need, and these are explained in the further slide. So as you can see here, we have 2 different types of parameters, which are input parameter and dependent parameters. Here it is formulated as such as if you give a value, for example, in extra ham, if you give the value 0, and in the extra Gruyere cheese parameter, if you give it 0, the extra weight would be 0 in total, and this extra weight, the dependent parameter, is added to the output flow. And if you need any extra toppings, you would simply give them 1, and the extra weight would be added up at the end in the final product. So moving further, these I apologize for the smaller text, but I just wanted to put it there to show you how the processes for pizza tuna and pizza margherita are also created. So the input flows which are in the LCI are imported from the existing database, and the processes which are referred are indicated in the right column in the screen. And yeah. From these processes created, a product system is generated, and as you can see here, on the very right side you have the process pizza margherita at supermarket, and in the middle column you have the input flows, which also refer to the 4 stages which we saw earlier. And in the very first column in the left side, you can see all the background processes which are contributing to the input flows. So from these product systems, you can create a project to create multiple variants of these 3 different pizzas. Before that, I would like to explain about the method used here, which is EF method, and it is an impact assessment method for environmental footprint initiative. It contains about 17 different indicators, and as you can see here, there are few already in the impact category section, and below that you have compared product systems, where you add the product systems created earlier from the process, and you can change their names accordingly. And below that, there's a parameter section where you can just manipulate the values of a particular product system to create different variants. For example, in the case of margherita, you give the parameters values as 0, but in the case of margherita with extra cheese, you give the parameter value of extra mozzarella as 1, so that it would create a different variant with extra cheese. So in total, you have 6 different pizzas, and which amounts to 6 kilograms total. And as I mentioned in the assumptions earlier, if the demand is about 6 kilograms of frozen pizza, these variants would add up to the demand. After creating the project, you have a small button at the top which generates a report, and this is how single indicator results would look like in openLCA. And this particular graph shows the eutrophication terrestrial impact category, and you can easily toggle among the graphs by using the interactive drop-down button in the report. And here clearly, as you can see, the variant margherita has the lowest impact, and the Reiner with extra cheese pizza has the highest impact in this category. Also, along with the raw data and single indicator results, you also have the relative results of how 6 pizza variants would impact the 17 indicators. It would show you the relative results, not the exact absolute values. However, you can quickly get an idea on which pizza or which variant is having a higher impact in one particular category, which is side by side. So in this graph, if you can keenly observe, in the first case, acidification terrestrial and freshwater, the tuna with extra cheese has highest impact when compared to cancer human health effects category, where rhino with extra cheese has higher impact. Moving on to the interpretation, a generic trend which is observed is that pizza with extra cheese always has the higher impact, which is predictable, and also pizza margherita without any toppings. The regular margherita has lesser impacts, in almost all the categories except for ecotoxicity of fresh water. Also, it is rather difficult to point out with absolute with certainty, but also the rhino variants has a higher impact on human health, eutrophication, and land usage indicators, and while tuna variants has higher impact on climate change and ozone depletion categories. So a basic fundamental suggestion would be to, if the supermarkets order the production of vegetarian or pizza with less cheese, that would have lesser impact on environment compared to the meat versions or with extra cheese variants. So this is the case study which I performed, and this is very basic and fundamental, although it has a lot of scope to further extend the study, where you could compare it with the hamburger or even with the vegan versions of pizzas. Also, you could extend the study into use phases, and the disposal phases. And also, inventory analysis can be performed by using the calculation in product systems for particularly finding out what is the amount of carbon dioxide released into the air, and so on and so forth. So I hope, apart from making you hungry, it also made you aware of how AGRIBALYSE is used in openLCA, and LCA analysis can be performed. Thank you for this opportunity, and I would like to hand over it to Tim.
Yeah, thank you, Suhas, for the presentation. I think it's a really nice example of showing how you can use already existing processes from the AGRIBALYSE database and tweak them a little bit so they fit your model, and it shows how useful this database can be. Now I would like to introduce Vincent again, and he will finish up his part of the presentation and talk about how you can use AGRIBALYSE database maybe for situations even outside of France.
Thank you, Tim and Suhas. Indeed, we thought it would be useful to provide a few advice about how to use our database in a different context, because we know that our first focus is on French users, but we think it has much broader potential. What is important is, if you're not in a French context, is to really consider for the agricultural products climate and soil condition of your area. And mainly, you can check if the yield and the input intensity is rather similar. You can be quite confident using AGRIBALYSE data. If you have very big difference, then you should probably try to consider remodeling. The consumption mix also is really specific to France, and each country has different import origin. And so that's also something to check if you're in a different country. For the processing, this is very specific to France because it's mainly electricity, and French mix is very specific with a lot of nuclear energy. So if you're in a different country, for the processing, you should at least adjust the electricity background data, which is quite easy to do in openLCA or any LCA software. For the packaging, we believe it's mainly the end of life which will be different, because packaging will be quite similar according to the country, just waste management that differs between the countries. And there you also have some scenarios that you can implement in the LCA softwares. The logistic in Europe will be quite similar. If you're in another context, you have some regulation and transport efficiency and distances that can be quite different. Considering the variety of products that is available, well, AGRIBALYSE is really reflecting a Western diet. So if you are in Asia or in Africa, there are a lot of products that you people eat, and we don't eat much in Europe. So you will have quite many data gaps. And also all the DQRs, the data quality indicators, are really built for considering the French context. So if you're using the data in another context, you should adjust the quality indicator ratio. We are also going on with the analysis, and we will share with some publications, and that will help the users to better understand the database. Well, the key ideas is that we really think the database is suitable as a first approach for European country if you don't have your own national database. It's a robust and transparent modeling framework. So what's powerful about the tool is that you can really adjust any hypothesis, any steps. It should not be used directly for southern countries. We also had some difficulties with many import products where we could not find data in the existing databases. So we really encourage every country to make some data publicly available about the production, domestic production. And we are really also happy to consider possible collaboration for European projects. So if you have some interest, please come and contact us for future. And we also hope that it can be an inspiring project for some other countries or other people. The last poll was to ask you a bit about what's your expectation about LCA data, which would be for you the key information and the key developments that you would expect in the future. So we let you answer, and I think we can go on with the presentation. So, well, this is a major step, as I said, this release of AGRIBALYSE 3.0 this summer, but the program will go on, and we have still a lot of things to do and to improve. Well, we have first a corrective patch that is currently being developed because we identified it's punctual mistakes, and it's inevitable in when you have such a large quantity of data. But for example, we realized that in cider, we forgot the glass bottle. So we have some specific mistakes that we identified, and we are correcting that right now. And we will also make a new version in October this year with all these correction available. We also know there's further work on some indicators for better accounting for soil carbon, pesticide impact, biodiversity. So this is more research work, and we need to go on working. So there are the recipes where we will consider probably making some industrial recipes for some products where we know that it's very different than home recipes. There are still some very big gaps for some products that are consumed largely in France. So for example, we had to use proxy for mushroom, for salmon, for honey, so which are very common products. So we should include them in the future versions. A lot of work to do about industrial processes. And if we want to also look further, we can try to not only provide an average product, but also provide benchmark for organic food. For example, we know for imported products, deforestation is very important contributor to the environmental impact. So we could make two alternatives. So one with a deforestation-free label and one standard product to highlight the benefits. That's something we're gonna discuss with the AGRIBALYSE partners to see where we put our priorities in the future, but we will make some new developments in the coming years. I'm getting to the end. What's we want to share is our vision that the database should really be considered as a knowledge basis for many tools and solutions. So we will not develop tools ourselves, but we really encourage that agriculture company, food companies, for the restaurants, there are lots of useful things that can be done based on AGRIBALYSE data to assess by the menus, recipes, and so on. And so that's why we provide public data, and we really hope people will connect their tools to our data. So that's the case for all the eco-design approach and all the environmental information of the consumers as well. And so it's important that people understand that it's a big work. We really think it's useful, but it's also evolving, dynamic, and there will be some improvements to come. And we also need the user community to help us to identify and to build those improvements. So that's why we have all the documentation. We try to provide all in French and English. In English, you can easily contact us. We have an email address, a contact form, so everything is on the web page. We want to encourage a more contributive approach in the future, and we hope that we will be able to provide a new version by the end of 2021. Well, so that's the end of my presentation. We hope we provide a really useful and innovative tool for the LCA community. We really want that those work are considered even broader than the LCA community, and that it becomes that all the companies, when they talk about sustainability, they consider the LCA approach and our works to define their strategy. We really want to be continue to be more and always more user focused and provide what you really need. And also that we really believe that you're more than users, you're experts, you can be contributors, and you're also ambassadors. So it's important that if you think that the data are useful to you, and then you talk about them, that you say that you have this AGRIBALYSE tool that is available for free, and that around you, your colleague, your networks, they know about it. And we still have our small team here. And so if we want to communicate, we need your support as well. And here is the email address. And I'll be really glad to answer your question and any requests.
Well, thank you, Vincent. I think AGRIBALYSE is a really interesting project, and I hope it will help promote LCA not only in France, but everywhere in Europe and in the world. Now I would like to show you how you can actually get the AGRIBALYSE database into your openLCA. So first and foremost, the most important thing is that both openLCA and the AGRIBALYSE database are for free. So you can just get them whenever you want and get started. All our databases for openLCA are on our Nexus website, so nexus.openlca.org. And if you don't have an account yet, you can just register here for free with your email. And when you do that, you can log in and get into our database website. So here we have a list of all the databases that we offer to you. For example, here the AGRIBALYSE database. And here you will find all the important information that you need to know. A lot of it we already talked about now in the presentation, but we also put it here so you can read up on it. And if you want to download the database, you basically just click on here and you can download it for free. It will then transfer you to the download page where you then choose the AGRIBALYSE database, which is available for openLCA versions 1.8 and newer. Right now we are at the 1.10 version. And yeah, just download it and then you already have it. What you're also going to need if you want to calculate some LCA results is a method package. And the method package that works with the AGRIBALYSE database is this one, our most recent method package 2.05, which is of course also available for free. Concretely, if you want to get your database into openLCA, you just open the software, you right-click anywhere on the navigation tree, and you say Restore Database. And then basically you just find the location where you save the zip file of the database, and it will import it into your program. The second step then is to actually get the methods into your database. So you right-click again on the then open database AGRIBALYSE, and you just say import. And then you can choose this JSON LD format, which is the format that we are using for our methods. And again, then you just go to the folder where you have saved the zip file with the methods. You click on finish, and then you have the methods in your database. What we recommend is that you use the EF method. So the EF method is made by the, basically, well, made by a lot of people, but it's a project from the European Union, environmental footprinting. And there's a special EF adapted method that can be used for the AGRIBALYSE database. Right, so it's very simple, and I think now we would go to the Q&A session. We can already see on the YouTube chat window there's a lot of questions, and we would just go through all the questions one by one and answer them together with Vincent. So let's start with the first question. So I think it's directed at Vincent. What are the fields where you see most space for improvement in the database?
I think I answered a bit in the final part, but well, we have new agricultural products that are definitely missing. There is a processing that is very complex with a lot of different food technologies that we are not reflecting properly. And there is, I think, a big work, and this is not so much about AGRIBALYSE, but all the LCA community to better reflect the impact on biodiversity of the agricultural practices. I would say that's the key topics.
Okay, thank you. The next question is, I use openLCA version 1.7 and it fails to import the eco-invent dataset. Can you please elaborate why this is happening? Yes, so the AGRIBALYSE database includes these eco-invent datasets, but it's only supported in versions 1.8 and newer. What you can do is to just download a newer version of openLCA. I recommend the newest one, 1.10.3. It's going to be better and faster anyway than the 1.7 version. In some cases, it can be maybe you're working for a big company and you can't just install software. In this case, you can just download a zip file that you can run directly, so you don't even need to install openLCA. You can just run it from the folder, and then you shouldn't have any problems importing eco-invent. The next question is, in the case study, SUAS used the EF method. Is this the recommended method to be used with the database? Definitely yes. So a bit of background maybe for this EF method. EF is for environmental footprint. That is a very big project by the European Union. The background is that the European Union is trying to basically in the future give every product an LCA that can be sold on the market here. And of course, that only makes sense if every one of these LCA uses the same methods and the same methodology for comparability. And EF is basically the one that we're using for that. So AGRIBALYSE went ahead and already created an adapted method for their database, which is very helpful, because then we can just use that in the future for future comparison with everything else in Europe. Another question for Vincent. I'm not sure if you mentioned it already. Do you include food waste during each phase of the life cycle?
I did not go into the detail in the presentation, but yet we consider the food waste at each stage, except the food waste for the consumers, that food that would be lost because it's not consumed in time or this kind of things. But for the losses during the production phase, it's considered, yes.
Right, so you're saying that you don't know what the consumer does, so it's hard to...
Exactly.
Okay. Well, thank you very much. I think that is all the questions that we have so far. Thank you for everyone who's watching, and special thank you to Vincent for presenting the entire database to us. And yeah, please go ahead, download openLCA. download AGRIBALYSE and just get started. And if you have any questions, feel free to contact us or contact Vincent.
Thank you, team, and thank you all the team for organizing the webinar. And I hope we have gone with a good discussion on this project.
I think so. Thanks everyone for watching. Have a nice day and bye-bye.